Okay, Bismillah. Okay, folks, welcome to looking at our lesson on circle geometry, the 6 rules. We have circles. Rule number 1, angles standing on the same arc. So the arc they're talking about is where? Where's the arc? Okay, I'll try my best to make it as smooth as possible. It's not always. This here is arc. Arc is a part of a circle. So angles standing on the same arc of a circle are equal. So which angles are they talking about? They're talking about this angle here and this angle here. Because both of these angles come from, if you look over here, if you follow me, let's use a different highlighter. So we got this line here, down here. So this angle here is made from this arc. Yeah, can you see that, folks? Okay, just do a different color. So here's the same arc, starts here. There's the arc, the yellow one. I'm going to make another angle, come down. So what they're talking about here is these angles in here. Okay, let's change it. This thing is a bit lethargic sometimes. So this angle here is the same as this angle here. Now, this particular question here is an exaggeration of this question, and I'll show you which part has been exaggerated and which part. So now the yellow part that was in the first question is now this really long yellow part in this question, but it's still the same question. That is an arc, a really big arc. What they've done, they've got these points here, these 2 points, and they just move them up to the side. Okay? Now, so we have here this angle here, that one, and this one are equal. That's what we're saying here. So let's have a look at the questions involved in these. So let's move forward. Okay, here we go. Let's make it a bit bigger. Okay, let's have a look at this question together. We can do this question together. So get your pens, pencils ready, and let's get cracking. If you've got your highlighters, the colors with you, use them too. Okay, calculate the size of each lettered angle. Hey, anybody has got a sheet, please pass them to him. That's a sheet. That's a sheet, please. Thank you. Who's that? So, when we do the question, we got to be thinking about the rule. So, in this particular question here, so we are talking about this is the arc. This is the part of the circle that we're talking about. Okay. Now, let's look at the angles that involves. So which is the angle that involves that one? It's going to be this one and this one. So this is 50. So B will also be 50 because here's the angle here. So the first triangle is here. Okay, the second angle is here. This is so difficult to draw the line straight. There's your triangle. Now, what can we say? Let's clear that. This is being messy. This is 50. So this B will be also be 50. So B is equal to 50 degrees. Fill that in over here. Okay, now, we have an arc on the bottom. We also have an arc on the, where's the arc? At the top. Okay, so the question's got 2 parts. Not only are these 2 angles equal, if you consider the opposite arc, that gives you this angle here, 30, and this one comes with the same arc, and the A. So we can say now that the A is equal to, what's A equal to? 30. Okay, are we happy with that? So if we had to explain that in the examination, what would we say? We would say angles standing on the same arc of circle are equal. Okay, so we need to mention that in our answer. But for the moment, all we're doing now is fill in the angles. Next question. Let's have a look at the next question. So we have an arc here sideways. Now here we go. So based on this arc, okay, which angles will be the same? This one and this one. Okay. So if I look at a different arc here, I have another arc over here. Based on this arc, which angles will be the same? This one and that one. So we can quite easily and quickly start filling in the numbers. So that's 40. So C will also be 40. This one's 25. So this one will also be 25. Okay. Now, in the next question, we have an additional rule. Now, what happens, for example, when we have this line and this line? What happens to the angle inside it? What do you call it? So we say this angle here, these are called, and this one, what happens to this two angle? They are? So opposite, yeah, vertically opposite angles are, what's the rule for that? Equal, that's it. So we've got an extra rule applying in here. So that's 80. So F also has to be 80. Okay. Now, where are the arcs for this question? The arcs are where? We have our arc here. Here's our arc. And this particular arc, what will it bind together? Okay, this arc will bind together what? Which angles? G and E. So these two will be equal. Now if you look at the arc at the other side, what will that bind together? That will bind these angles. These angles are equal based on the arc. So we can now go around filling in angles. So 80, 80 is done. This is 70 over here. So Hassan, this will also be 70. If that's 70 and that's 80, what do we know about the angle sum of this triangle? So what do you say about this triangle here? This triangle here, the angle sum is equal to, you have to write that in the exam as well. So when you start filling in these things, you say, so we say, how do we get G? So we can say G is equal to what?
20.
Okay, but we have to give the meaning for it. So G is equal to 180. 180 minus 70 minus the 80. That's how we work it out. Because it involves all those added together. So G is equal to 180. Take away 70 over 80. So that will give us the missing angle. So 70 add 80 will give you 150. So the missing angle will then give us an answer of 70 at 80 is 150. So 180 altogether, that will give us an answer of 30. So G is equal to 30. So we've done a couple of rules. The rules that we use first, angles standing in the same arc of a circle are equal. Therefore, H is equal to 70. So that's the reason. Same again, angles standing in the same arc of a circle are equal. Therefore, G is equal to E. But before we done that, we said the angle sum of a triangle is equal to 180. So G is equal to 180 minus 70 minus. So we're explaining and we're writing down the rules as we go along. At the moment, I'm just verbalizing them to you at the moment. You should be writing them down somewhere. Okay, so what's E going to be equal to now then? E is also going to be equal to 30. Okay, are we happy with those top 3 questions? So we're given the answers and we're given the reason why. Okay. I'm going to have to clear that page and move it up. I've already cleared it and move up now, yeah? Okay, let's have a look at these questions now. So here we go, we have our arc starting here and finishing here. That's one arc. This is a Another arc. The first arc, what are the equal angles of the first arc? What's equal? Which angle is equal, folks? You can't talk in this lesson. On this first arc, which angles are equal? I and J. So put them in one color. Based on this second arc over here, which angles are equal? 30 and K. Now we've got everything color coded, we can start filling them in. So K is equal to 30. Now, that is a 90 degrees angle. So Samara, if this is 30 and that is 90, how do we work at J? Give me the mathematical method for working at J. What do we say? We say that the angle sum of this triangle, whatever it is, in the examination, what would you say? You have letters for the angle sides. So the angle sum of triangle ABC, for example, is equal to 180. Therefore, at angle J, okay, that particular one, the angle J is equal to 180. What's the calculation? Minus 90 minus 30, which will give us an answer of 60. Okay. So remember, in the examination papers, we have to explain each step of what we're doing. Here we're just verbalizing it. Okay. So J is equal to, if J is equal to 60, what's I equal to? Why is I equal to 60? Because angles standing on the same arc of a circle are equal. So when you say that in the examination, you get to put that statement with it. Okay? Yes, Seth? Okay, next one. We've got to work out this angle here and this angle here. So we have 150 degrees outside. So the angle, what do we say about M? How do we work out? What's the mathematical explanation for M? Okay, I'm going to dictate, you guys have to write down. So M, tell me about how do we work out M? Okay, that's the calculation. What's the math behind it? Well, how would you? Okay, I'm going to be more precise now. Angles at a point on a straight line add up to 180. Therefore, M is equal to 180 minus 150. That gives you an answer of 30. So when you give the answer to the examiner, you've got to get the definition bang on, right? You know, angles on a straight line adds 180, that's actually wrong. So wrong. Angles at a point on a straight line add 180. So we need to get our definitions up. So write that down, please. Write down somewhere for M. There, on that piece of paper in your book. Question 5, part 1. Angles at a point on a straight line add 180. Therefore, M equals 180 minus 150 equals 30. That is the mathematical proof of how M is equal to 30. That's how, and you get the full marks for that examination. Okay. Write it down. Get used to writing it down. Okay, what is this angle equal to? I'm going to call it X. What's X equal to? We say X is equal to, what angle is equal to? What's the angle X equal to? M. Y is equal to M. Angles standing on the same arc of a circle are equal. Write that down. In your books, write that down. For angle, this angle X there. Okay? Write it down. I can't see your pen moving fast unless you're writing it down in your head. So for angle X, X is equal to angles standing on the same arc of a circle are equal. We need to get used to this. Okay? So we know that M, what did we say M is equal to? We said M is equal to 30. M is equal to 30. So we know that X is equal to 30. And we know that this L angle here is equal to 150. Y is equal to 150. Same reason we gave first. Angles at a point on a straight line equal add up to 180. So that L will be equal to 180 minus 30. So you have to explain it, do the calculation, and write that all down. Because you'll be doing an exam. That's the format of the questions. Give the answer, and how did you get the answer? What's the rule behind the answer? So you got to keep on giving the rules. Okay, let's have a look at question number 6 in context of the rules. So when you give me an answer, okay, Saf, what is the angle N? Start with the rules.
Angles at a point on the straight line add up to 180 degrees.
So N is equal to, so then N is equal to, what's the calculation for N then? N is equal to
N is equal to
180
minus 150.
160.
160 equals
20. Excellent. Lovely. Okay. Right, let's have Ifra. Give me the mathematical reason for us working on angle P. How do I work out P mathematically? What's your... so we know N, we know this angle here, we just don't know P. So we would say to work out P, what mathematical rule do we know?
Angles at a point.
Angles inside a
Triangle.
add up to
160.
180. Okay. So 110 add 20 add P is equal to 180. So P would be equal to 180 minus. That's right. So P would be equal to 180 minus 130, isn't it?
Yeah.
So P is equal to 50. So that's how we work it out.
So I have 180 minus 20 minus 50.
You can, but I'll just simplify it.
The examiner will you mark us down if you want?
Not necessarily, but it's better to do 180 minus 110 minus 20. Because then it shows exactly what you're looking at. That's better. Okay, so we worked out P, we want to work out Q. So Abdullah, give me the mathematical definition for how we would work out Q. So Q, angles,
Angles at a point on a straight line equal to 180.
equal to 180. Therefore,
P
Q
Q
equals
Q equals
180 minus
50.
9. Which will give us an answer of?
30.
Yeah? 130, yeah? So, we know that one, we know this one, we know that one. We can work out R and S now. What can you tell me about R? What can you tell me about R?
It's
I'll give you a clue. I'll color code it for you.
it's
Okay.
it's
Angle R is equal to angle P. Because angles standing on the same arc of a circle are equal. We have to say that in that sentence. Therefore, if that's 50, then R is also equal to 50. And the answer, the reason for S would be again, angles at a point, and a straight line equals 180, so S is equal to 130. Okay? So we need to go around these questions and give the mathematical reason for them. It's not hard, is it? Just gotta know what they are. Okay. Right, we're gonna do some more of these questions together, and then I'm gonna let you loose on some of the questions, and you have to write down all the mathematical reasons for each step of it that you learned. What we're doing now together first. Okay, are we happy with the questions from rule number 1? Okay, right. How many questions do we have left now on that sheet? Okay, do them, please. She likes 160. So that's 40, that makes the height or whatever the angle there is as 40, okay? Yeah? Happy with that one?
yeah.
Okay, lovely. Good. Okay, we're looking at rule number 2 now, folks. We're back to recording in. So here's rule number 2. Who's reading rule number 2 to me?
Sorry.
Yeah, go on.
The angle which an arc subtends at the center of the circle is twice that which is subtended at the point.
Okay, right. Now, I know the words sound quite old school here, but that's what you need to write in the exam. That's what, in the examination mark scheme, that's the language that comes up. So you need to memorize these, and the more you practice writing the questions out, the more it'll be easier for you. So, the angle which an arc, here's the arc here. The angle is subtends at the center is double that which is subtends at the top. That's it. That's what it is. Okay, should we move quickly on to these questions? Here we go. Here's the question. These ones should be nice and quick. So, let's have a look. Okay. Right, we've got a pen not coming off our plane. Okay, it is like that. Here's my back up now. Okay. What's going on behind there? Okay, right, let's... Okay, folks, look at rule number 2 now. We have an arc over here. and it says that the angle which an arc subtends at the center, here's the center one, this one here is always double of the one it subtends at the circumference. So if this is 100, this is double of A, we can quite easily work out A. A is equal to 50 degrees, easily. Now, here's 140, Samara, what is angle B? B straight away, it has to be an angle of 40. Angles at a point here, on a straight line add up to 180. So angle B is equal to 180 minus 140, which is 40. Now that we know this angle here, how do we work out this angle here? What do we say for that one? We say the angle which an arc subtends at the center of a circle is twice that which subtends at the circumference. So this one is double of that. So C is equal to 80. Now you might find this surprising, but this shape here is really this shape in disguise. If you get the legs of this shape and you push it up here, from like round here, you get the shape here. So this is really the same as this shape, but it's been distorted. There's these two legs here. These two legs have been split, moved to here. That's how we're going to move here. So that point stays there. That leg goes to there, that one goes there. It's the same shape, but a very different orientation of it. Now, so where's our arc in this question? Our arc is where? Our arc is here. And the angle subtended at the center is this one. And this is double the one is subtended at the top. So that's 200. The other one will be 100. Done. So we've done those couple of questions. Okay. Here's some more questions. Right. Okay, Mr. Saf, what's this angle here?
130.
130. Why is it 130? Give me the mathematical reason. Vertically opposite angles are equal. That's it. That's the reason for that be 130. Now, what is angle F? Angle F is equal to 260. Why is that? The rule. The angle which an arc subtends at the center of a circle is twice that which subtends the circumference. You have to regurgitate that in exam. That's why it's 260. Okay, you happy with that? Yep. Good. Next one. Again, you know this bit here, this corner here. Where was it originally? In our old shape, it was up here, wasn't it? So really, the chevron that goes up here, all they've done here is got that point there, and then moved it down here. It's still the same shape. But what shape is it? It's still one of the chevron shapes that we had in the previous question. So that's the angle at the center, and that's the angle at the circumference. So G will be equal to 40. Because the one at the center is always double the one at the circumference. Yes? Okay. 160. So what's H going to be equal to? 20. This is the angle at the circumference. What will be the angle in the middle? It will be double of it. 40. Okay. Okay, number 7. So that's 20. What do these two lines here mean? Equal. So these lengths are equal. That's isosceles triangle. So that's 20. This will also be 20. If that's 20, then this angle here will be 140. Why? Because the angle sum of a triangle is equal to 180. 180 minus 20 minus 20 is 140. That's how you explain the exam, yeah? Now, the angles at a point on a straight line are equal, add up to 180. So K is equal to 40. Okay? Now, next one we say, to work out L. Angle which an arc subtends at the center is double that at the circumference. So L or I is equal to 80. Write in the answer and given the reason. Write in the answer given the reason for each question. Okay. What can we assume about this line here and this line here? That they are both the same because they are both radius lines. From the center to their radius. So they haven't told us it's isosceles, but we know by looking at the line. It starts at the center, it goes there. It has to be equal. If this is 50, then this will be also be equal to 50. If these both are 50, the angle sum of a triangle is equal to 180, so n is equal to 80. If n is equal to 80, the angle which an arc is at the center of a circle is twice that of the circumference, so that's 80, then that one has to be 40. If this is 40, some of these two are angles at a point in a straight line, that will have to be 140. We write in the answers, but we give an explanation. Writing the answers and verbalizing, writing down the explanation. Because in the examination, you have to give the explanation. It's 140 because of this. It's 40 because of this. Okay. If this is 220 here, what will this angle here be on the other side? That will be what? 140. Because 140 or 220 gives you 360. Okay. If that's 220 here, and this one is double of the one on the other side, so R will be equal to 110. If that's 140 here, the question upside down. This one is in the center, that's double of this one, so T will be equal to 70. Why? Because the angles which an arc subtends at the center of a circle is twice that which is subtends the circumference. Done. We've got the answers and we've given a reason. We've got the answer, given a reason. How many questions are left on the page? 3.
Yep.
Do them please, me now. So here are the answers for question number 10, 11, 12. Recording. Rule number 3 states that if you have an angle in a semicircle is a right angle. That's the definition. Angles in a semicircle is a right angle. So if you have a triangle in a semicircle, that angle will always be 90 degrees. Okay. So let's start filling in some of these. So this angle here has to be 90. Why? Because the angle in a semicircle is a right angle. 90 at 40, so that is 130. So that leaves us, oops, sorry, one shouldn't be there, pardon me. That's just 50, sorry folks. Not 1, just 50 degrees. Done. Okay. Okay, we can work out the other angles as well. Okay. Angles in a semicircle is right angle. That's exactly what is in the examination papers as answer. The angle in a semicircle is 90, is a right angle. So here's a semicircle, half a circle. So the angle has to be 90. That's 90. That's 120. So this angle here will be 60, because angles at a point in a straight line equal to 180. 60, 90, angles in a triangle add up to 180. So C will have to be 30. Done. In this next question, you might think, how do we answer a question with no angles on it at all? There's an angle on there. Angles in a semicircle is a right angle. That's 90. What do these two lines mean? Isosceles triangle. So the remaining 90 has been split into half, so that will be 45, 45. Done. Okay. Go back to recording. Okay. Right. So we have here. Now, it says AB is equal to BC. So this length is equal to this length, which makes this triangle into isosceles. So that's 20. So G will straight away be 20, because isosceles triangles, these two angles equal. 20 at 20 is 40. 40 from 180 gives us 140. That's how we work that one out. Angle sum of a triangle is 180. Now, angle sum at a point on a straight line is 180. So that is equal to 40. Now, angle in a semicircle is a right angle. So this angle appears as 90. 90, 40. So J will straight away be 50. That's how we work out. That's how we go around this question. Now, here's our triangle. Follow my pen on the board. Here's my triangle in a semicircle. So the angle in a semicircle is equal to 90. If that's 90, that will also be 90. 90, 90, 55. So this one here will be 35. Because 90 at 55 at 35 is 180. angle sum of a triangle. If that's 35, then that one will be, what will it be? 55, because that's the right angle there as well. That's 55, then that one will be 35. Done. Here we go. We've got two right angle triangles in a semicircle, one on each side. If that's 30 here, that will be 30 here. And this angle here at the top there has to be a 90. That's 30, then that one will be then 60. That's how we do the questions. Because I know this, I know that. Because this is 90, that's 60. And we literally go bing, bing, bing around the question and we fill them all in. Yeah? So here's our triangle in a semicircle. So this is the angle at the circumference. So that one has to be 90. That's 70. So this one will now be 20. If this is 20 and this is parallel lines, M will also be 20. Now, what do we know about this line and this line and this line? They are all equal because they're all radii. Okay? So that makes this triangle into a isosceles triangle. So that's 30, then that would also be 30. 30, 30. And we know this triangle is in a semicircle, so this altogether will be 90. So this automatically will be 60. Done. Questions done. And that's how we move with these kind of questions. We quickly bing around them. But in the examination, we have to explain it. So it's a bit longer in the examination. Okay, we need to move on to some other rules now. We're running out of time. Rule number 4. I love rule number 4. Rule number 4 is a nice, lovely rule. What is rule number 4? Somebody read to me rule number 4.
Angles in a cyclic quadrilateral.
Okay. Angles in a cyclic quadrilateral add up to? Okay, sorry, the opposite, pardon me. The opposite angles of a cyclic quadrilateral add up to 180. What's the word cyclic mean? It goes around in a circle, in a cycle. So this quadrilateral touches, each corner touches the circle. So what we're saying here, I'm going to highlight them for you. What we're saying here is that this angle here is opposite. So that means these two must add up to 180. That's what you write in the examination. So you would say B is equal to 100 because the opposite angles in the cyclic quadrilateral add to 180. So 80 and 100 is 180. So you have to explain that in the exam as well. So B is equal to 100. Let's change color. So this is 50 and this is the opposite angle in the cyclic quadrilateral. So A will be equal to 130 because opposite angles in the cyclic quadrilateral add up to 180. So it's equal to 130 because of all of this. You have to say all of this as well. Yeah? Happy? So write it down. Some of the explanations with it. And that's what we're looking at today. The explanation. Why is something what it is? That's 80. That's 100. That's 50. And that is 130. Lovely. So you can smash through these questions. They're so easy. That's 85. So this one here will be, what will it be? 95. That's 95. The opposite one on this side will be 85. If this one is 75, this one will be 105. You could literally do it by looking at it in seconds. But for the examiner, we must say D is 105 because opposite angles of a cyclic quadrilateral is 180, add 180, and then 180 minus 75. Okay? Are you happy with that? So we can see quickly what they are, but we have to a bit more longer for the examiner. So we can literally smash through this page now, literally like a tornado. So this is 110. So this will be automatically
70.
If that's 70, then the opposite one will be, because opposite angles of cyclic quadrilateral equals 180. That's 115. This one will be, what is it? 65. Done in seconds. Actual answers. Explanation might take another minute or so. That's 130. So this here will be what?
That one will be 50.
50. That's 50 inside. That will be outside.
130.
130. If that's 120 outside, that will be inside. What will it be? 60. If that's 60 inside, the opposite one will be 120. Done. Okay, that's how we do these questions. We just look at them and do them. Obviously for the examiner, we do them and then we explain it as well, as we said. Right, everybody else finish those questions off. I'm moving the page up a bit. I don't want anybody looking up at the board because I'm doing the answers now on the board. So you guys look down, do your work. Look, I saw Harun says, Trivilla. I shouldn't have said that. I should have just done it quietly. That's 100. Sorry, I think I'll give you a point as well. 80. Talk about it. Okay. Answers. So number 5, number 9 answer important there for you. 5. Okay, yes, keep Jimmy out of the class. Question number 5. The angle between a tangent. Okay, who knows what tangent is? Explain to me what tangent is. Tangent, which part of the line is it? Tangent is a line that just about touches a circle. Okay, my highlight is a bit wonky there. That's to be expected. Okay, the angle between a tangent and a radius is always a right angle. Whoa. Well, that is just so difficult to do. That's right angle there, by the way, folks. One of my big right angles. Okay, the angle between a tangent is the yellow highlighted line, and a radius, which is the turquoise line, is always 90 degrees. Okay, folks, have you got that rule? So we're saying here, this angle here is 90. Between this line and that line. Between this line and that line, that's another 90. And that's all the rule is. You can state that rule when we do the next questions. Okay. Right, let's move on to the next questions. Good. Okay, number 5. Right, let's make this a bit bigger. Who's Jimmy? What's he doing in my class? Jimmy's the bird. You're not whiting it in, are you? Okay, this one we're going to do really quickly. This one. Now what do we say? We said the rule for number 5 is the angle between a, can you say please? The angle between a tangent and a radius is a right angle. Let's say it again. The angle between a tangent and a radius is a right angle. That is the rule. Let's do it now. Okay, here we go. Okay, here's my radius. Look, here's my radius. Here's my tangent. So this angle has to be 90. That's 90, that's 60. The angle sum of a triangle is 180. So that will have to be 30. Okay, here's my tangent. Where's my tangent? Oh gosh, that's quite... Oh. Here's my tangent here. Here's my radius here. So the angle between those two has to be... And these two lines indicate its isosceles. So this has to be 45. And this one has to be 45. Yes, Jimmy. Okay. Okay, here we go. Here's my radius, Samara. Here's my radius. And this line here is my tangent. So the angle between the radius and the tangent has to be 90. 90, 90, that's 180, and this has to be 180 as well. So C will be equal to 140. Excellent, well done. Okay, right. This is our radius here. This is, look at the pen moving. This is the radius, and this line here is the tangent. And the angle between those two has to be a 90. So that's 90, that's 35. So this angle here will be, what will it be, folks? 55, because angles in a triangle add up to 180. If that's 55, Samara, what will that angle there be? E? It will be 125. Okay, if that's 125, what will F be? 55, because these two got added to 180. Look, these two are 180 and these two are 180. Done. Now, I said done and not done. Okay, here's our tangent, here's our radius. So the angle between these two must be, that's 35, then that will have to be And these are vertically opposite angles, so that will also be, and that one will also be 90, and that one will also be 35. Done, 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 done. Jimmy. Okay. Right. What I would like you to do, have a go at question 6, and we're going to move on to the next type now. Everybody do question 6. Done? Part 6. Okay, here comes part 6. The angle between a tangent. Okay, now I've got my own like special way to explain this one, but we have to learn this. The angle between Z flick. Remember that? The angle. Somebody remember that? Z flick. Okay, the angle between a tangent and a chord equals. Hang on a second. Let's move up a bit. Angle between a tangent and a chord equals the angle in the opposite segment. That's like a very mathematical language. I just call it the Z flick. I'll show you what I mean by that. Here comes our Z. Start at the tangent. Go along the chord. Can you see the Z happening now? There's the Z. Yeah? And then you flick the Z at the end. Okay. What's wrong with Jimmy? So this angle here will be equal to, that's what the rule actually means. I call it the Z flick rule. So we make our Z in the tangent, along the chord, along the triangle, and then flick the end of the Z. So this angle here in the knee part, the opposite of the knee, is equal to angle. But when we give this answer in the examination, we must regurgitate all of this. We need to memorize it. Okay, are we happy with number 6? Okay, for shorthand, for like a quick one, we call it the Z flick. But when you explain it, you must explain the angle between tangent. Okay, let's move on. Okay, so going back live, folks, part number 6, angles in the opposite segment. Let's use a highlighter. So, here we go. That's the tangent. This line here is called the, what's this line called? It's called the chord. And then we take and make a Z. And the last part of the Z is called the Z flick. So we flick the Z down here. And then we say that this angle here, inside the Z flick area here, is equal to the angle there. That's what the rule is saying. The rule states the angle between a tangent and the chord equals the angle in the opposite segment is talking about this angle here. That's the kind of mathematical way of saying what I've just said. So if that is 60 here, then we know the C is equal to, C is also equal to 60. Now, this triangle here is, we said this is an angle in a semicircle, the right angle. So this is 90. So that means B must be the remaining part of the 90, which is 30. Okay? You happy with that? So 2 rules are coming into there. Okay. Remember, we are looking for the tangent, the chord, and the opposite segment. So let's do the next question. So we start at the tangent, then we go along the chord, we make the Z, and then we flick it. And then we highlight this. This is the angle here, which is equal to the angle there. Okay, so we said now that if this angle here is 60, then this angle here will be 60. And the reason why that will be 60 is because the angle between a tangent and a chord equals the angle in the opposite segment, which is 60. Okay, so I've missed out A in the previous question. That's a radius, that's a tangent. So altogether this angle has to be 90. That's already 60. So A is left over, so A will be equal to 30. Okay, thank you for pointing that question out. So we are looking for z's. Okay, folks, Asaf, are we looking for z's or are we just talking to Jimmy? Okay, where's the z? Here's the z. And there's the flick. So here's E, and there's 75. So both of these, so angle E is equal to 75. The answer is the angle between a tangent and a chord equals angle in the opposite segment. So there's the tangent. Here's the chord. So this angle is equal to angle in the opposite segment. Done. That's our reasoning. We can have forward z's or backward z's. Now, I'm going to give you guys a few minutes while I switch the projector off this time. And let you guys do the rest of the questions on this page. Folks, now that you've had a go at those questions, I'm going to put the answers on now. Switch the projector back on so you guys can see what answers I've got. If you're spotting obvious mistakes, please put your hand up. Okay, right, here we go. So remember I said I call it the Z flick. So we start from the tangent, we go along the chord, we make the Z, bring it back down. So this angle A is equal to this angle. So that's 50, that will be 50. Okay, that's 70, 50 is 120, that will be 60, that will give you 180, that will give you 110, that will give you 70. Or you can do backwards Z flick as well. Here's another Z flick. Small this way, tangent, then we have, after our tangent we have a chord, and then the opposite segment. So these two are equal. This one and that one equal. That's 25, that's 25. That's 85, 25, 110, that's 70 in the middle. 70, 25, that's 85. Job done. Here, backwards Z flick. Tangent, after tangent we have our chord, and then opposite segments here. So this 20 matches that 20, that's already 110, that's 130, that's 50, that's 70, that's 110. Done.
It's not 8. Not 8. You missed the T.
Oh, okay, Mr. T, I'll put that in. Okay, so we have 75 here, do the Z, flick it, this 75 there. Okay, you know these are isosceles, so that's 75, that's also 75. So backward, here's the Z, another Z flick, so this is equal to that one, so we fill that one in from there. If that's 75, that's 75. 75 and 75 is 150, 4 minus 130, that's 30. 8. Number 8. So we have here 80 at 40 will give us 120. So this angle here will be 60. 60 at 80 is 140 and that will be 40. Missing angle. Okay, and that one will be 40, 100, so that's 80, that will be 100. Our isosceles triangles are both 40. Next question. We have our Z flick. So this 75 is that's 75. And because there's also parallel sides, so you have this thing called alternate angles equal. That's 75, that's 75. So that's both 150, that's 30, done. Abdullah, you happy?
Yeah.
You good with that?
Yeah.
Okay. And some more interesting ones at the bottom. Okay, have you finished the 6 types now? Okay, have you got any more pages left in your booklet now? We've got part 7 and mixed, yeah? I want you now to have a go at those 2 pages and finish them off. So I'm going to give you about 10 minutes of those. Okay folks, now what you can see now, coming up on the board, some more lights again, switch off please. It's part 7a mixture. These are the solution set. Okay, so if you can mark these against yours, the ones you got wrong, can you mark them wrong and tick them up? And for some of you who haven't actually done any questions, can you fill them in?
Yeah, definitely so.
Yeah, I know you're there.
The ones I got right, I've marked them.
You better zoom in.
No, if I zoom in, then no, I can't zoom in.
Twice.
Yeah, I think
Because then it will, the numbers will match the thing. Okay. 60, 70, 50.
Okay.
I'll go around, okay? A is 20, B is 20, C is 70. Okay. It's just a light changing, that's all. 55 for M, N is 55, and that one is 40. X is 60, Y is 30, Y is 70, X is 35. 100, 50, just the lamp's warming up, colours going to be more brighter. 140, that becomes 40, that's 80. That's 80, that part there will be 100. Okay, so that makes these two into 40, 40. So I missed these ones out here, that's 140, that's 220.